Hello, Algebra 2. Welcome to our review for the Unit 7 quiz. This should be fun. It'll be great. Here's a list of formulas and equations that I would highly recommend you memorizing. This is the vector form for a parabola. Here's the generalized form for a parabola. Can you go from one direction to the other and vice versa? In the vertex form, you want to pay close attention to where your x's are and where your y's are, because with the first one, where y equals a lot of stuff, you're going to get a happy face or a sad face, and for the x equals a bunch of stuff, you're going to get a sideways face. As for your circles, this is your standard form. This is usually the nicer form to making a circle, and here's your generalized form. Can you go from one direction to the other? As for the ellipse, this ellipse is going to be centered at the origin. So you have an ellipse that goes just right here where this is your center. In the standard form that is not centered at the origin, do you have an ellipse that goes somewhere to the side? There's some shifty going on. So let's apply some of these and answer some questions. Converting from general form to vector form. Easiest way to do that is to complete the square. So let's isolate my x's by themselves. That's fine. Y minus 5 equals, I'm going to give myself some space because I know I'm going to plug something in. 2, 8x, and I'm going to leave this blank. So what is the mystery number that I'm going to add into here so that I can turn this into a perfect square? The formula that we're looking for is b over 2 squared. So we're going to take this b, which is 8. So half of 8 is 4. Squared is 16 plus 16. You do it to one side, you have to do it to the other side. That being done, this is going to turn out to be x minus 4. Over on this end, I have y. 16 minus 5 is 11. 11. Bring everything to one side. So minus 11, and I have y equals x minus 4 squared minus 11. Let's try that again. This time I encourage you to do it yourself. Pause this video, figure it out. I'm not going to wait here all day, so you can pause me, and I'm just going to continue on. Let's isolate my x's, so plus 6, and I have y plus 6, give myself some space, x squared plus 12x. What is the magic number I'm going to add over here? Half of 12 is 6, squared is 36, plus 36, plus 36. I'm going to have a perfect square on this end, which is x plus 6. Over here, I'm going to have y plus 42, minus 42, minus 42. And I'm going to be left with y equals x plus 6 squared minus 42. Any questions on that one? If you have a question, you can always email me. Okay, this should be quick and easy, but we're already in vector form. How do we find, or we're already in vertex form. How do we find the vertex? If we remember on our equation, the vertex in vertex form is going to be negative h and k. If y is your lead, then it's going to be negative k and y and h. So pay attention to your x and pay attention to your y's. For this first one, we have y equals x minus 3 squared minus 6. So our minus 3 is just going to be 3, and since we have a minus 6 here, it's going to be a minus 6. Over on number 4, we have negative 5, because negative 5 is going to be positive. That's how it works out. And a 12. Lastly, we here pay close attention to what your lead is. So we have an x equals negative y minus 4 squared plus 5. So in this situation, this is a k, and this is your h. They swap because k always associates to the y, and h always associates to the x. So our HK coordinate vertex is going to be 5 and 4. Pay attention to where the x's and the y's are. Graphing the parabola. Always pay attention to your x and your y's. Over here we're looking at x equals negative y minus 4 squared plus 3. So in this case, this is your k and this is your h. When we pay attention to that, we're going to move to the right 3 and up 4. Our coordinates are 3 and 4. Because we have a leading coefficient of a negative, we're going to be opening to the left. Left is like the sad face. Right is happy face. I have no better way of memorizing that one. Over here is y equals x plus 5 squared minus 4. This one's our standard parabola, happy and sad. Since it's a positive coefficient, we have a happy face somewhere, and our vertex is going to be negative 5, negative 4. So looking at this out, we're going to go left 5 spots, and then down 4 spots. And we have a happy face. Cool. Graph the circle from standard form. Standard form, we can look up or just remember that x minus h squared plus y minus k squared equals r squared. We have both numbers are set up in the negatives, which makes it easier, so we just have 6 and 5. Our r squared is 16, so our r is 4. Keep in mind, this number right here is r squared, and if I'm looking for r, you have to take the square root of that. R squared, to get to r, needs a square root. So we're going to graph this out. We're going to go all the way to the right by 6. 1, 2, 3, 4, 5, 6, and then we're going to go up 5. 5, and 4 is our distance. Yeah, nice. All right. Following the same formula that we know in these, x plus 4, that means our h is a negative 4, because minus negative 4 gives you your plus 4. It's 9, and our r squared is 49, meaning our r is 7. Plotting this out, we're going to go back 4, up 9. Oh man, this is way out of bounds for, all right. So 1 point here, 1 point here. And let's start graphing onto the other graph. 1 point here, and somewhere high up here. There you go. Write the equation of the circle from, this is general form, into standard form. Ooh, general form. How we're going to do that? By completing the square. But in this case, completing multiple squares. So we're going to group all of our x's together and all of our y's together. So let's put x squared minus 8x, give yourself some space, plus y squared minus 4y, give yourself some space, equals 5. We're going to start adding some things onto that 5 in a second. what is the magic number that we want to add in here to get a perfect square? Keep in mind the b over 2 squared. So half of 8 is 4. 4 squared is 16. So plus 16. Add to one side. You have to do to the other side. Over on this one, we have half of 4 is 2. Squared is 4. Plus 4. Plus 4. Perfect squares that we're going to get. X minus 4 plus y minus 2 equals 16 plus 4 is 20. 20 plus 5 is 25. 25. I chose a very nice number for you all. You're welcome. When we plot this out, we're going to go, our center is going to be 4, 2, and our radius is going to be 5. Because r squared is on the right side, and you have to take the square root to get r. Center is 4, go over 4, up 2, and we're going to get a circle of 5. So, and one more point. That is not a circle. Boo. Yeah, that's at least a circle. Don't judge me, nobility. Don't judge me. All right, can you group your letters together? Pause this video. You know, little Bowser says you can do it. And you can. We believe in you. Graph this out. So pause the video if you need to. Otherwise, let's do some grouping. X squared plus 12x. Give yourself some space. Plus y squared minus 16y. Give yourself some space. Equals 0 in this case. So half of 12 is 6 squared plus 36. Half of 16 is 8. Squared is 64. So that is 36 plus 64. Add that together, you get 100. I do choose nice numbers for you all. X plus 6. Y minus, because remember the signs follows the middle term. 8 squared. So my center is going to be -6, 8. My radius is 10. Oh, this is a huge circle. Okay. 6, -6, up 4, 1, 2, 3. I think that counted, right? Yeah, so this is your center, and we want to go, this is 1 point, or, actually, no, that's not even 1 point. This is 1 point. This is 1 point. You got some point probably over here, some point probably over here. Yeah, there's your circle. Good, go with it. Did not plan it to be that big, but I wanted clean numbers, so you got clean numbers, just giant circles. Again, you can do it. Moving to ellipses. An ellipse centered at the origin. Well, if it's going to be centered at the origin, I know my point is going to be right here, so the easy answer is 0, 0. What is my a going to be? My a squared is 64, and my b squared is 9. So my a is going to be 8, and my b is going to be 3. Because I like to write down what I know does not move on the vertex. For the x vertex, the y's don't move, so I know that these y's stay the same. For the y vertex, I know that the x doesn't move, so these are going to stay the same. Over here, I'm going to have plus b and minus b, so -8 and 8. over here, I'm going to have negative 3 and 3. As for the points that these go to, let's shift over, well, not shift over, but count out from 8. 1, 2, 3, 4. Counting by twos. 2, 4, 6, 8. Up 3, down 3. Nope, that is not the shit that I want. I'm just gonna, I don't want to be shamed again. That's my ellipse. I hope you like it. It's good. It's fine. It's fine. Similar problem here. Can you do it yourself? This is at the origin, so we know our center is going to be 0, 0. What is our A? 5. What is our B? 9. Plug what we know. For X, Y's don't move. So I can just plug in the Y's in those spots. For Y vertex, I know that the X's don't move, so I can just plug in what was the X's there, which was 0, 0. Now we're going to do some of the shifting. Not shifting, but some of the adding and subtracting. So A goes with the X's, plus and minus. So I have a negative 5 and a positive 5. B's affect the Y's. So I'm going to get a negative 9 and a positive 9. Ellipse this out. We're going to go back 5, forward 5, up 9, 3, 6, 9, 3, 6, 9. That's my ellipse. That one actually turned out okay. Kind of fuzzy on the right side, but you get the cross. All right, challenge upgrade. Now we're doing a shifty ellipse. So what is my A going to be? My A is going to be 6, and my B is going to be 8. These numbers give you your A squared and your B squared. Now, what is my H and K for the center? Given that our formula is x minus h squared over a squared plus y minus k squared over b squared equals 1, our h is going to be negative 3, and our k is going to be 2. Let's plug in what we know isn't going to shift. X vertex, the y's don't shift. So we can plug those in. In the y vertex, the x's stays the same. So only these numbers now we have to solve for. And these are going to be the numbers that go x plus minus a, and this one is y plus or minus b. So let's plug in what we get. So we're starting off at negative 3 minus 6 gives me minus 9. Negative 3 plus 6 gives me 3. On this one on the bottom, we can go the location of 2 minus 8 gives me negative 6, and 2 plus 8 gives me 10. This is quite a large ellipse. So negative 3, positive 2. So this is my center, and we're gonna go negative 9, 3, 6, 9, 2. So 1 point right here, 1 point over here. Oh, that's okay. Not there. Right here. Going up to 10, 2, 4, 6, 8, 10, and down to negative 6, 2, 4, 6. That is your shifted ellipse. And last but not least, can you do this last shifty ellipse? I believe in you. You can do it. Even Dad Bowser is here cheering you on. You can do it. Go, little Bowser. Sorry, I don't mean to call you a Bowser. Anyways, let's find what our A's are. A is gonna be a 2, and our B is gonna be a 4. Our center is gonna be 5 and -1. The A came from here, the square root. The B was the square root of this. Your center is this H and this K. As for vertices, for the x's, we know that the y's don't move, so let's just plug in what we know don't move. For the y vertices, we know that the x's don't move. Let's keep those in place. Plug in the numbers that we have left. So 5 minus 2 is going to give 3. 5 plus 2 gives you 7. We have -1 minus 4 gives you -5. -5 plus, oh, not -5, but -1 plus 4 gives you 3. Let's graph this out. Our center point is to the right 5, down 1, point here. We're going to have 3, -1, and 7, -1. Going up and down, we're going to go 5, -5, this one here, and then 3 here. That's your ellipse. This is your review. Please feel comfortable with shifty of ellipse, centered at the origin ellipses, how to get your circle, how to convert from general form to standard form and graph it, how to use vector forms, vertex forms. You've got this. Good luck.